Workshop 4, Part 3, video talk through. We are now on step 7, so we've generated our power spectrum using the raw CO2 data and the Fourier transform method. And step 7 says, okay, note there's a lot of energy at low frequencies that is associated with the overall trend of the time series. So if we look back at our original time series, then you can see that this linear trend, if you like, the Fourier transform is trying to fit a very long sinusoid to this. So this could look like a little bit of a very long period wave, which just carries on like this. Okay, and if we look at the power spectrum, then the outcome of having this trend is that we have a lot of energy at very low frequencies. Okay, we see periodic components at 1 per month, twice per month. That's probably not enough certainty above the noise here to say that there's anything here. But the biggest peak by far is at very, very low frequencies, and we don't see anything that looks like a periodic component at low frequencies other than this trend. So this trend can really bias your spectrum to low frequencies. So it looks like you've got energy at very low frequencies, when actually the bit that you want to pick up is this strong periodic component here. And you can see that peak, that this is it here, but it really is appearing quite small in our power spectrum. Okay, so what we need to do is detrend this time series. We want to remove this linear trend, and MATLAB quite fortunately has a very good function. We don't need to do linear regression and then remove it. MATLAB will do this for us with its detrend function. So moving on to step 8, it says detrend the time series using a simple linear fit. So MATLAB is a function that does this. Try doc detrend. So let's try that. Doc detrend, and see if you can figure out how to use it. Y equals detrend of x. So detrend removes the mean value or linear trend from a vector or matrix. It's usually for FFT processing. Okay, so there we go. Good reason why people do that before you process your data to produce power spectrum. Okay, so detrend of x removes the best straight line fit from vector x and returns it in y. So in other words, what we want to do is we want to detrend our time series y. So we want to put ry in here. Okay, so let's just close that for a moment. And we could type in y detrend, y det is equal to detrend of y. Okay, and perhaps we'll just try plotting that. Open up another figure window and plot t, comma, y detrend, y det. Okay, it looks like that, so good. That's what we'd hope. So this is what the output is once you've removed the linear trend from the time series. And this y det, the detrended time series, is now what we will put into our Fourier transform method. So